November 17, 1943. North Atlantic Ocean, 240 nautical miles southwest of Iceland. Captain Lieutenant Klaus Weber pressed his eye against the periscope of U-427, watching the convoy's escort vessels through the grey morning mist. In 43 seconds, everything he understood about submarine warfare would prove catastrophically wrong. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Weber had commanded U-boats for 18 months, surviving encounters that had claimed 70% of his fellow commanders. His crew trusted his tactical expertise, earned through 27 successful patrols, and 11 confirmed merchant vessel sinks. The Royal Navy's escort patterns had become predictable to experienced commanders like Weber, their depth charge attacks following established procedures that skilled submarine crews could often evade through practiced maneuvers. But the British destroyer HMS Starling was preparing to demonstrate a weapons system that would render 2 years of hard-earned submarine warfare knowledge obsolete in less than 60 seconds. Weber's hydrophone operator, Obergefreiter Hans Müller, reported the familiar sounds of approaching escort vessels. The acoustic signatures matched standard British destroyer patterns that Weber had encountered dozens of times previously. Convoy HX-217 appeared to follow routine protection protocols, with 6 escort vessels maintaining defensive positions around 43 merchant ships, carrying vital supplies to Britain's war effort. Weber calculated attack vectors using tactical knowledge that had kept U-427 operational, while sister boats had been destroyed attempting similar approaches. The convoy's speed, approximately 8 knots, created opportunities for submarine positioning that experienced commanders could exploit. The escort vessels maintained patterns that left predictable gaps in defensive coverage, allowing skilled submarine crews to penetrate convoy protection through careful maneuvering and precise timing. U-427's crew prepared for attack procedures that had proven successful throughout the Atlantic campaign. Torpedoman First Class Friedrich Steiner loaded the forward torpedo tubes while plotting firing solutions based on convoy movement patterns. Engine room personnel reduced power to minimize acoustic detection while maintaining sufficient propulsion for rapid maneuvering after torpedo launches. Radio operator Wilhelm Braun monitored communications frequencies for convoy position updates and escort vessel coordination signals. Weber had studied Royal Navy escort tactics extensively, analyzing reports from other U-boat commanders who had survived convoy attacks. British destroyers typically responded to submarine contacts by conducting depth charge attacks using established search patterns. These attacks, while dangerous, followed predictable sequences that experienced submarine crews could anticipate and evade through evasive maneuvering and deep diving procedures. The tactical situation appeared routine to Weber's experienced assessment. U-427 possessed favorable positioning relative to convoy course and speed. Weather conditions provided adequate concealment while maintaining acceptable visibility for periscope observations. The submarine's mechanical systems operated within normal parameters, ensuring reliable performance during combat maneuvering. Weber's crew demonstrated readiness levels that reflected months of training and operational experience. However, HMS Starling carried experimental weapons that would transform this routine engagement into a demonstration of technological revolution in anti-submarine warfare. The destroyer's forward deck mounted a device that Weber had never encountered in previous engagements, a weapons system that British naval engineers had designed specifically to overcome the tactical limitations of conventional depth charge attacks. Weber ordered attack preparations while maintaining periscope observations of convoy movements. Standard submarine tactics required approaching the convoy from positions that minimized exposure to escort vessel detection, while maximizing torpedo effectiveness against merchant targets. Weber selected approach vector that had proven successful in previous engagements, calculating timing that would allow torpedo launches before escort vessels could implement effective countermeasures. The British convoy proceeded according to patterns that Weber recognized from intelligence reports and operational experience. Merchant vessels maintained formation discipline, while escort vessels conducted routine patrol sweeps around convoy perimeters. Radio intercepts suggested normal operational status without indications of heightened alert levels or unusual defensive preparations. The tactical environment appeared consistent with previous convoy encounters that had resulted in successful submarine attacks. Weber's confidence reflected expertise developed through extensive combat experience and comprehensive training in submarine warfare tactics. German naval doctrine emphasized aggressive convoy attacks using proven tactical procedures that had achieved significant success during the early phases of the Atlantic campaign. U-boat commanders like Weber represented the elite of German submarine forces, selected for independent command based on demonstrated tactical skill and operational success records. The periscope observations revealed convoy composition and escort arrangements that matched intelligence estimates provided during U-427's pre-patrol briefing. Merchant vessels included tankers, cargo ships, and transport vessels carrying materials essential for British war production and civilian survival. The escort force consisted of destroyers and corvettes, equipped with standard anti-submarine weapons that U-boat crews had learned to counter through tactical innovation and operational experience. Weber initiated approach procedures that had proven effective during previous convoy attacks. U-427 maneuvered to positions that provided optimal torpedo firing solutions, while minimizing exposure to escort vessel detection capabilities. The submarine's crew executed movement sequences with precision developed through repeated training exercises and combat operations. Each crew member understood his responsibilities during convoy attack procedures, ensuring coordinated execution of complex tactical maneuvers. The hydrophone operator reported acoustic contacts consistent with convoy vessel movements and escort patrol activities. These sound signatures matched established patterns that German naval intelligence had catalogued through extensive monitoring of Allied shipping operations. Weber used this acoustic information to refine positioning calculations while maintaining periscope observations of surface vessel movements and formation changes. HMS Starling's commanding officer, Commander Peter Gretton, had received specific instructions regarding the deployment of experimental anti-submarine weapons against German U-boat threats. The Hedgehog system represented revolutionary advancement in anti-submarine warfare capabilities, designed to overcome tactical limitations that had allowed experienced U-boat commanders to evade conventional depth charge attacks through skilled maneuvering. The weapon system fired 24 contact-fused projectiles in predetermined patterns that created lethal zones around suspected submarine positions. Unlike conventional depth charges that detonated at preset depths regardless of target proximity, Hedgehog projectiles exploded only upon direct contact with submarine hulls. This contact-fusing technology eliminated the acoustic warnings that typically alerted submarine crews to incoming depth charge attacks, preventing evasive maneuvering that often allowed submarines to escape destruction. Commander Gretton had trained extensively with Hedgehog operations, understanding both the tactical advantages and operational limitations of the new weapons system. Successful Hedgehog attacks required precise positioning and accurate target location estimates, demanding enhanced coordination between detection equipment operators and weapons system personnel. The experimental nature of Hedgehog deployment meant that operational procedures were still being refined through combat experience and tactical evaluation. Weber began final approach sequences while observing escort vessel positions through periscope sweeps. The tactical situation continued to appear favorable for submarine attack, with escort vessels maintaining routine patrol patterns that created opportunities for torpedo launches against merchant targets. Weber calculated firing solutions based on convoy speed and course, while positioning U-427 for rapid departure following torpedo launches. The submarine's torpedo room personnel completed final preparations for coordinated attacks against multiple convoy targets. German torpedo technology had achieved high reliability rates when properly maintained and skillfully deployed, providing submarine commanders with effective weapons for convoy interdiction operations. Weber selected targets based on strategic value and tactical accessibility, prioritizing vessels whose destruction would significantly impact Allied shipping capabilities. HMS Starling's radar operators detected suspicious surface contacts that suggested possible submarine periscope exposures during convoy approach maneuvers. The destroyer's crew implemented heightened alert procedures while maintaining normal convoy escort responsibilities. Commander Gretton ordered tactical preparations for potential anti-submarine operations, while avoiding actions that might alert submarine commanders to increased detection risks. Weber maintained periscope observations while finalizing attack preparations, unaware that British detection capabilities had identified U-427's presence and general position. The submarine's approach procedures followed established tactical doctrine that had proven effective during previous convoy engagements. Weber's crew demonstrated professional competence and operational readiness that reflected extensive training and combat experience. The moment of weapons deployment approached as both submarine and destroyer crews prepared for engagement that would demonstrate the revolutionary impact of technological advancement on naval warfare tactics. Weber possessed tactical expertise and operational experience that had enabled successful submarine operations throughout the Atlantic campaign. Commander Gretton commanded experimental weapons capabilities that represented fundamental transformation in anti-submarine warfare effectiveness. Weber ordered torpedo firing preparations while positioning U-427 for optimal attack geometry against selected convoy targets. The submarine's crew executed final approach procedures with precision and coordination that reflected months of training and operational experience. Weber calculated timing that would maximize torpedo effectiveness while minimizing exposure to escort vessel countermeasures. At 0847 hours, Weber gave the command that would initiate an engagement demonstrating technological revolution's impact on established military tactics. U-427 began torpedo attack procedures, while HMS Starling prepared to deploy weapons that would forever change submarine commanders' understanding of surface vessel anti-submarine capabilities. The periscope crosshairs aligned with the selected merchant target as Weber prepared to order torpedo launch. Behind him, his crew maintained stations with professional competence earned through extensive combat operations. The tactical situation appeared routine to experienced assessment, promising another successful convoy attack using proven submarine warfare procedures. Weber could not have anticipated that HMS Starling's response would introduce him to weapons technology that made conventional submarine evasion tactics catastrophically inadequate. The destroyer's Hedgehog system represented engineering advancement that transformed anti-submarine warfare from approximate area attacks to precise contact-fused engagements that eliminated traditional submarine escape procedures. The engagement was about to begin that would demonstrate how technological innovation could render years of tactical expertise obsolete within minutes, forcing submarine commanders to recognize that their hard-earned operational knowledge had become dangerously insufficient against revolutionary weapons systems designed specifically to overcome established submarine warfare tactics. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The story of the Hedgehog anti-submarine weapon began not in naval engineering laboratories, but in the desperate calculations of British Admiralty officials who watched merchant shipping losses mount to unsustainable levels throughout 1942. By September of that year, German U-boats had sunk over 3 million tons of Allied shipping, threatening Britain's ability to continue the war effort. The traditional depth charge, while psychologically intimidating, had proven tactically insufficient against experienced submarine commanders who had learned to exploit its fundamental weaknesses. Captain Charles Goodeve, Director of Miscellaneous Weapons Development at the Admiralty, recognized that conventional anti-submarine warfare had reached a technological dead end. Depth charges required escort vessels to pass directly over submarine positions, allowing targets time to maneuver away from attack zones. The weapons detonated at predetermined depths regardless of target proximity, creating noise and turbulence that masked submarine movements while rarely achieving direct hits. Most critically, the acoustic warning of incoming depth charges provided experienced submarine crews with sufficient time to implement evasive procedures that often prevented destruction. Goodeve assembled a team of engineers and naval tacticians who understood that revolutionary improvement required abandoning established approaches entirely. The team included Lieutenant Commander Hedley Boyden, whose experience commanding destroyer escorts had shown him the tactical limitations of existing weapon systems. Engineering expertise came from Dr. Robert Fairley, whose work on contact-fused munitions provided the technical foundation for precision anti-submarine weapons. Naval gunnery specialist Commander James Morrison contributed tactical knowledge about projectile delivery systems that could maintain accuracy under maritime conditions. The development team faced engineering challenges that had prevented previous attempts at contact-fused anti-submarine weapons. Traditional naval projectiles were designed for surface targets or predetermined depth explosions, requiring different fusing mechanisms than those needed for submarine contact detonation. Contact fuses needed to function reliably after water impact, while distinguishing between submarine hulls and false targets such as debris or marine life. The delivery system required accuracy that conventional depth charge launchers could not provide. Dr. Fairley's breakthrough came through analyzing captured German contact mines, which had demonstrated reliable underwater fusing mechanisms during Baltic Sea operations. The German technology used hydrostatic pressure differentials to arm contact fuses after submersion, preventing accidental detonation during handling and transport. Fairley adapted this principle for anti-submarine projectiles, creating fuses that armed automatically upon water entry, while maintaining sensitivity to submarine hull contact. The projectile design evolved through extensive testing at the Admiralty's experimental facilities in Portsmouth. Initial prototypes used conventional explosive charges that proved insufficient for submarine hull penetration. Enhanced versions incorporated shape charge technology borrowed from anti-tank weapons development, creating projectiles capable of penetrating submarine pressure hulls even at oblique impact angles. The final design balanced explosive power with projectile weight, ensuring adequate terminal effectiveness while maintaining delivery system accuracy. Lieutenant Commander Boyden developed tactical deployment procedures that maximized Hedgehog effectiveness against submarine targets. Unlike depth charge attacks that required escort vessels to approach directly over submarine positions, Hedgehog could engage targets ahead of the attacking vessel's course. This approach prevented submarines from using escort vessel passage time for evasive maneuvering, while maintaining continuous sonar contact throughout the attack sequence. The forward-firing capability allowed escort vessels to maintain sonar contact during weapons delivery, significantly improving targeting accuracy. The delivery system presented complex engineering requirements that pushed naval weapons technology beyond existing capabilities. The weapon needed to fire multiple projectiles simultaneously in predetermined patterns that created lethal zones around suspected submarine positions. Each projectile required identical ballistic characteristics to ensure pattern consistency, demanding manufacturing precision that exceeded conventional naval munition standards. The mounting system needed to withstand repeated firing shock while maintaining accuracy alignment under maritime conditions. Commander Morrison's gunnery expertise proved crucial in developing the spigot mortar system that became Hedgehog's distinctive feature. Traditional naval guns fired single projectiles using contained propellant charges, requiring complex mechanisms for multiple projectile delivery. The spigot mortar concept used individual propellant cartridges for each projectile fired simultaneously through electrical ignition systems. This approach provided pattern consistency while simplifying mechanical complexity compared to conventional multi-barrel weapons systems. The pattern geometry received extensive analysis to optimize submarine destruction probability while maintaining reasonable ammunition requirements. Mathematical calculations showed that circular patterns provided optimal coverage for typical submarine dimensions and maneuvering capabilities. The 24 projectile arrangement created overlapping lethal zones that accounted for targeting errors while ensuring adequate coverage density. Pattern diameter could be adjusted through propellant charge variations, allowing tactical adaptation to different engagement scenarios. Testing programs at Admiralty experimental ranges revealed Hedgehog capabilities that exceeded initial design expectations. Direct contact hits achieved submarine destruction rates approaching 100%, compared to depth charge success rates below 15% during actual combat conditions. The contact-fused projectiles eliminated the acoustic warning that allowed submarine evasion, creating tactical surprise that prevented defensive maneuvering. Most significantly, failed attacks produced no underwater explosions, maintaining sonar contact that enabled immediate follow-up attacks. Production planning required establishing manufacturing capabilities that could deliver Hedgehog systems in quantities sufficient for widespread escort vessel deployment. The Admiralty contracted with multiple engineering firms to ensure adequate production capacity while maintaining security around the revolutionary weapons system. Vickers Armstrong provided heavy manufacturing capability for the spigot mortar assemblies. British Thomson Houston contributed electrical firing systems and control mechanisms. Smaller specialized firms produced the contact-fused projectiles under strict quality control standards. Training programs for Royal Navy personnel emphasized the tactical advantages that Hedgehog provided over conventional anti-submarine weapons. Gunnery officers learned pattern adjustment techniques that optimized effectiveness against different submarine types and tactical situations. Sonar operators received instruction in targeting procedures that maintained continuous contact during weapons delivery sequences. Engineering personnel mastered maintenance procedures that ensured system reliability under combat conditions. The first Hedgehog installations occurred aboard Royal Navy destroyers operating in the western approaches, where U-boat activity remained heaviest throughout 1943. HMS Starling received her Hedgehog system in September 1943, with Commander Peter Gretton supervising installation and crew training. The system integration required modification of forward deck structures and installation of electrical systems that connected the weapon to the ship's sonar and fire control equipment. Commander Gretton's initial assessment of Hedgehog capabilities recognized the tactical revolution that the weapon represented for anti-submarine warfare. Unlike depth charges that attack general areas where submarines might be located, Hedgehog attacked specific positions where sonar contact indicated actual submarine presence. The precision targeting eliminated the guesswork that characterized conventional depth charge attacks while providing immediate feedback about attack effectiveness through contact detonation or lack thereof. Operational procedures for Hedgehog deployment required coordination between sonar operators, weapons personnel, and bridge officers that exceeded complexity of conventional anti-submarine attacks. Sonar contacts needed precise bearing and range information to enable accurate pattern placement. Weapons crews required rapid firing capability to engage submarine targets before evasive maneuvering could negate targeting solutions. Bridge officers needed tactical flexibility to position ships for optimal weapons delivery, while maintaining convoy escort responsibilities. The psychological impact of Hedgehog on Royal Navy escort crews proved as significant as the tactical advantages. Previous anti-submarine attacks had offered limited feedback about effectiveness, creating uncertainty about whether depth charge attacks had achieved submarine destruction or merely forced temporary submersion. Hedgehog provided definitive results through contact detonation, giving escort crews confidence that successful attacks had eliminated submarine threats. Security measures surrounding Hedgehog development prevented German naval intelligence from understanding the revolutionary capabilities that British escort vessels would soon demonstrate against U-boat forces. The Admiralty classified all information about the weapons system at the highest security levels, restricting knowledge to personnel directly involved in development, production, or deployment activities. Even Royal Navy personnel not directly involved with Hedgehog operations received no information about the weapon's existence or capabilities. German naval intelligence continued analyzing British anti-submarine capabilities based on conventional depth charge technology, failing to anticipate the tactical transformation that Hedgehog would introduce to convoy escort operations. U-boat tactical doctrine remained focused on evading depth charge attacks through established procedures that would prove catastrophically inadequate against contact-fused weapons systems. German submarine commanders retained confidence in tactical expertise that had enabled successful operations throughout the early phases of the Atlantic campaign. The stage was set for revolutionary demonstration of technological advancement's impact on established military tactics. HMS Starling and other Hedgehog-equipped destroyers prepared for convoy escort duties that would introduce German submarine forces to weapons capabilities that made conventional evasion procedures obsolete. The tactical surprise would prove devastating for U-boat crews who had learned to survive through expertise that no longer provided adequate protection against revolutionary anti-submarine technology. Captain Goodeve's vision of precision anti-submarine warfare was about to receive its ultimate test in the grey waters of the North Atlantic, where experienced U-boat commanders like Captain Lieutenant Klaus Weber would discover that technological innovation had rendered their hard-earned tactical knowledge dangerously insufficient against weapons systems designed specifically to overcome submarine warfare's established procedures and proven survival techniques. The development of Hedgehog represented more than engineering achievement. It demonstrated how determination to overcome seemingly insurmountable challenges could produce revolutionary solutions that transformed entire domains of military conflict. The weapon's success would prove that innovation driven by desperate necessity could achieve breakthroughs that conventional development approaches had failed to deliver. providing hope that technical ingenuity could overcome strategic disadvantages through creative application of scientific principles to tactical problems. Captain Lieutenant Klaus Weber possessed the tactical expertise that had transformed him from a junior officer into one of Germany's most successful U-boat commanders. His understanding of convoy attack procedures had been forged through 18 months of North Atlantic operations, where survival depended upon precise calculation and flawless execution of complex maneuvers under extreme pressure. Weber's approach to convoy HX-217 demonstrated the systematic methodology that had enabled U-427 to complete 27 patrols, while sister boats had been lost to Allied countermeasures. Weber's tactical analysis began with comprehensive assessment of convoy composition and escort arrangements. Through careful periscope observations, he identified 43 merchant vessels arranged in standard convoy formation, with 6 escort destroyers positioned according to established British defensive doctrine. The merchant ships included high-value tankers carrying aviation fuel, cargo vessels transporting military equipment, and transport ships loaded with supplies essential for British war production. Each target represented strategic value that justified the operational risks inherent in convoy attack procedures. The escort force composition revealed capabilities that Weber understood thoroughly through previous combat experience. The destroyers appeared to be standard British vessels, equipped with conventional anti-submarine weapons systems that U-boat commanders had learned to counter through tactical innovation and operational expertise. Weber's intelligence briefings had provided detailed information about British escort procedures, including depth-charge attack patterns that experienced submarine crews could often evade through skilled maneuvering. Weber calculated approach vectors that would maximize torpedo effectiveness while minimizing exposure to escort vessel detection capabilities. His preferred attack geometry involved positioning U-427 ahead of convoy course, allowing torpedo launches against multiple targets before escort vessels could implement effective countermeasures. This tactical approach had proven successful during previous convoy engagements, providing submarine crews with optimal conditions for achieving multiple target destruction while maintaining reasonable escape prospects. The submarine's crew preparation reflected months of training and operational experience that had developed exceptional coordination and professional competence. Each crew member understood his specific responsibilities during convoy attack procedures, ensuring seamless execution of complex tactical maneuvers under combat conditions. Weber had personally trained his personnel in emergency procedures and evasive tactics that could mean the difference between mission success and submarine destruction during escort vessel counterattacks. Oberster Hans Moller, Weber's hydrophone operator, possessed acoustic expertise that had proven invaluable during previous convoy encounters. Moller could distinguish between different vessel types through engine sound signatures, identify escort patrol patterns through propeller acoustic analysis, and detect changes in convoy formation that might indicate heightened alert status. His capabilities provided Weber with tactical intelligence that enhanced attack planning while reducing detection risks during approach maneuvers. Weber's torpedo attack procedures had been refined through extensive combat experience and technical analysis of weapon system capabilities. German torpedo technology had achieved reliability rates that exceeded 90% when properly maintained and skillfully deployed. Weber's crew had developed loading and firing sequences that minimized time exposure while maximizing accuracy against selected targets. The submarine carried sufficient torpedoes for attacks against multiple high-value targets, providing flexibility for tactical adaptation based on evolving combat conditions. The tactical situation appeared to favor submarine attack based on Weber's assessment of convoy vulnerabilities and escort limitations. Weather conditions provided adequate concealment for periscope observations, while maintaining sufficient visibility for accurate targeting. Sea state conditions remained within acceptable parameters for torpedo accuracy and submarine maneuvering. Most importantly, the escort vessels maintained patrol patterns that created predictable gaps in defensive coverage that skilled submarine commanders could exploit. Weber's confidence in attack procedures reflected extensive analysis of British anti-submarine capabilities and limitations. Royal Navy escort tactics emphasized area denial through depth charge attacks that required escort vessels to pass directly over suspected submarine positions. This approach provided submarine crews with tactical warning through acoustic detection of approaching vessels, allowing time for evasive maneuvering that often prevented successful attacks. Weber had survived numerous depth charge attacks through tactical expertise that exploited these procedural limitations. The submarine's mechanical systems operated within normal parameters, ensuring reliable performance during the complex maneuvering required for convoy attack procedures. U-427's diesel engines provided sufficient power for rapid surface transit and battery charging, while electric motors enabled silent underwater approach and evasive maneuvering. The submarine's diving capabilities allowed rapid depth changes that could evade surface vessel detection, while maintaining tactical flexibility for attack positioning. Weber initiated final approach sequences while maintaining periscope observations of convoy movements and escort patrol activities. His tactical calculations indicated optimal firing positions could be achieved within approximately 20 minutes, providing adequate time for precise target selection and weapons preparation. The submarine's crew executed approach procedures with professional efficiency that reflected extensive training and operational experience under combat conditions. HMS Starling sonar operators had detected acoustic anomalies that suggested possible submarine presence in convoy vicinity. The destroyer's detection capabilities had been enhanced through recent technological improvements that increased sensitivity to submarine acoustic signatures. Sonar operator First Class Thomas Mitchell possessed experience that enabled him to distinguish between submarine contacts and false returns caused by marine life or underwater debris. His assessment indicated high probability of actual submarine presence rather than equipment malfunction or environmental interference. Commander Peter Gretton received reports of possible submarine contact while maintaining convoy escort responsibilities that required careful balance between investigation and continued protection of merchant vessels. British escort doctrine emphasized immediate response to submarine threats, while avoiding tactics that might expose convoy vessels to increased attack risks. Gretton's experience commanding destroyer escorts had taught him to recognize the tactical indicators that distinguish genuine submarine threats from false alarms. The destroyer's crew implemented heightened alert procedures without creating obvious changes in patrol patterns that might alert submarine commanders to increased detection risks. This tactical approach required professional discipline and operational coordination that demonstrated Royal Navy training standards and combat readiness. Gretton understood that premature response to unconfirmed submarine contacts could compromise tactical advantage, while failing to respond adequately could result in successful submarine attacks against convoy vessels. Weber continued attack preparations while unaware that British detection capabilities had identified U-427's general position and tactical intentions. The submarine's approach procedures followed established doctrine that had proven effective during previous convoy engagements throughout the Atlantic campaign. Weber's tactical expertise and operational experience provided confidence in procedures that had enabled successful submarine operations against heavily defended convoys. The convergence of submarine attack procedures and escort vessel countermeasures created tactical conditions that would demonstrate revolutionary impact of technological advancement on established military doctrine. Weber possessed expertise and experience that represented the pinnacle of German submarine warfare capabilities, developed through extensive combat operations and comprehensive training programs. Commander Gretton commanded weapons systems that represented breakthrough innovation in anti-submarine warfare, designed specifically to overcome tactical procedures that had enabled submarine operational success. Weber's final approach calculations indicated optimal attack positions could be achieved through tactical maneuvering that had proven successful during previous convoy engagements. The submarine's crew prepared for torpedo attacks that would demonstrate German submarine warfare capabilities against what appeared to be conventional British escort procedures. Weber anticipated counterattack patterns based on established Royal Navy doctrine that experienced submarine crews had learned to evade through tactical expertise. HMS Starling prepared to deploy weapons capabilities that would demonstrate how technological innovation could render established military expertise obsolete within minutes of combat engagement. The Hedgehog system represented engineering advancement that transformed anti-submarine warfare from approximate area attacks to precision contact engagements that eliminated traditional submarine escape procedures. Commander Gretton understood that successful deployment would validate revolutionary weapons technology, while potentially eliminating submarine threats that had caused massive Allied shipping losses. the tactical engagement approaching would prove that individual expertise and operational experience, while valuable, could become insufficient when confronted with revolutionary technological advancement, specifically designed to overcome established procedures. Weber's tactical knowledge represented years of development under combat conditions, but it had been acquired through experience with conventional weapons systems that operated according to predictable patterns and limitations. Weber's crew demonstrated professional competence and operational readiness that reflected German submarine service standards and extensive combat experience. Their coordination and technical expertise represented capabilities that had enabled successful submarine operations throughout the Atlantic campaign, against heavily defended convoys protected by experienced escort forces. However, their tactical knowledge had been developed through encounters with conventional anti-submarine weapons that provided acoustic warning and predictable attack patterns. The approaching engagement would demonstrate that technological revolution could overcome individual expertise and operational experience through capabilities that made established tactical knowledge dangerously inadequate. Weber's confidence in submarine warfare procedures reflected genuine competence developed through extensive combat experience, but his expertise had been acquired against weapons systems that operated according to limitations that Hedgehog technology had been designed to eliminate. The tactical situation contained elements that would transform routine convoy engagement into demonstration of how innovation could revolutionize military capabilities while rendering previous expertise obsolete. Weber approached what appeared to be conventional tactical situation, using proven procedures that had enabled submarine survival and operational success throughout extensive combat experience. Commander Gretton, prepared to demonstrate weapons capabilities that would prove conventional submarine tactics had become catastrophically insufficient against revolutionary technological advancement. At 0851 hours on November 17, 1943, Captain Lieutenant Klaus Weber achieved what he believed would be another successful torpedo attack against Allied convoy HX-217. His targeting calculations had positioned U-427 in optimal firing geometry, with 3 high-value merchant vessels aligned for coordinated torpedo strikes. Weber's tactical expertise, refined through 27 previous patrols, indicated that convoy conditions favored submarine attack procedures that had proven successful throughout his operational experience. Within 90 seconds, this expertise would prove catastrophically insufficient against technological innovation that transformed every assumption about submarine warfare survival. Weber ordered torpedo launch sequences that followed German naval doctrine developed through extensive Atlantic campaign experience. The submarine's forward tubes released 3 torpedoes in precise intervals, each weapon programmed for specific target intercepts based on convoy speed and course calculations. Weber's crew executed firing procedures with professional competence that reflected months of training and combat operations under the most demanding conditions imaginable. The torpedoes traveled toward their intended targets while Weber prepared for post-attack maneuvering that would enable U-427 to escape anticipated depth-charge counterattacks. HMS Starling's sonar operators maintained continuous contact with U-427 throughout the torpedo launch sequence, providing Commander Peter Gretton with precise bearing and range information that enabled immediate tactical response. The destroyer's enhanced detection capabilities had tracked the submarine's approach movements with accuracy that exceeded conventional sonar performance standards. Gretton possessed tactical intelligence about submarine position and attack vectors that would enable Hedgehog deployment under optimal conditions for demonstrating the weapon's revolutionary capabilities. Weber's post-attack procedures followed established tactical doctrine that had enabled submarine survival during previous convoy engagements. He ordered rapid course changes and depth adjustments designed to complicate escort vessel targeting while positioning U-427 for emergency diving if surface counterattacks materialized. These evasive maneuvers had proven effective against conventional depth charge attacks that required escort vessels to estimate submarine positions based on limited acoustic information and predictable movement patterns. The first torpedo struck the merchant vessel SS Manchester Guardian, a cargo ship carrying military equipment and supplies essential for British war production. The explosion created dramatic secondary detonations as ammunition stores ignited, producing spectacular visual effects that confirmed successful target engagement. Weber observed the destruction through his periscope while calculating attack vectors for his remaining torpedoes, confident that his tactical expertise had achieved another significant victory against Allied shipping operations. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.